This is a presentation of what we're going to present at Facade Tectonics in Los Angeles in October. Our paper, Facade Technologies in Educational Methodology. My name is Roger Schroeder. I'm an adjunct professor at SUNY Alfred State. I've been there about 6 years, and one of the courses I teach is Advanced Structural Concepts, which is where this paper, the development of this methodology was focused. My co-author here is Joe Ebert. Joe may be present at the conference, so at this point he would introduce himself. If not, I will add in additional information about Joe. So we're going to talk about the paper, present the paper, but we want to go further than that. We want to kind of introduce to you our current explorations, where we want it to go, and then do that in a quick enough fashion so that we have time to critique and discuss what we're doing. So once again, setting the context, part of a course in Advanced Structural Concepts, the Facade Tectonics component is about 1/3 of the course, where we look at rain screens, unitized modular construction, embodied carbon. And the big idea here is that we can preset modules, actually components of a curtain wall system, with all kinds of technical details about how it's constructed, and then allow the student to use that pre-constructed module in order to develop a facade. So in practice, the students get to work creatively, creating the decorative or the elements of the facade, controlling the shapes of the panels, the colors of the panels, widths, heights. They can also control the shape of windows and other elements that go within that. And then they can unpack what they've done and actually explore the details that go along underneath that. So they can develop an understanding of the relationship between the glazing plane and the facade plane, where waterproofing and moisture membranes might need to go, etc. So a little visual illustration of how that works. So we have the module here on the left side, and then the tab that would appear in the Revit BIM modeling environment. And you'll notice down at the bottom of that tab, there are a bunch of visibility settings, of which the student can activate or the user can activate in order to see elements. So in this case, with nothing showing, you see just a piece of plywood now, modeled as plywood, or kind of a sheathing board, and a window inside that, which the student would custom construct. You can activate the moisture barrier in order to see the next layer, put the Z-girt on in order to support the track system that's going to support the terracotta tile system, insert the insulation, add the track system in by highlighting it, and finally add the tile system. And then by creating other tile systems within that, create different kinds of visibility systems. So by activating certain different shapes they create, they can vary patterns and create different kinds of facade hierarchies. So that's the overview, and then eventually they can then deconstruct that and expose parts of their elements to see what the underlying relationships are of the components. This is an example of a student's work on that. So the idea is that they made the different shaped tiles, they used color and patterning, and then could then pull through these nice rich construction details of how the assembly goes together. So the students really got a lot out of it. They thought the rain screens had a huge impact on the design aesthetics of a facade, the idea of all the stuff that was going on underneath, the idea of the modifications of shape and all. But we have some critiques about, the actual what was done as far as the learning environment. And so the critiques that you might have and we had are, is too much done for the learner? Is there limited flexibility in the way we presented this project? And alternately, positive critiques. Is it a simple and quick way to connect design details with design? And so I want to mention a little bit about course delivery. This is presented in video format. We work on the basis of the BIM modeler Revit, like most programs do. It's segmented into 8 to 10 minute sections, and it's step by step of how to go through and create this. Now, what's important to discuss about this idea of method of delivery is that, obviously with the move to or focus on the ability to do online learning, comes the realization that becomes a really accessible platform. People can access asynchronously, remotely. People who have no physical ability to access making physical models can do can do virtual digital models. So there's a whole host of ideas that spring forth from the underlying concept of this idea of creating these rich digital kind of virtual mock-ups. And the idea of video guiding them really creates an efficient learning platform for the student. So that's where we were, and this is kind of where we're going with that. So one of the modules, obviously, if you think about this is 3 weeks in a third of the course that we teach. So understanding rain to screen designs is the first part. Another one we do is this idea of modular construction and looking at curtain wall details. And then finally, we're introducing something that was developed in actually one of the introductory courses that we teach, and that's computer visualization. The idea of doing a facade exploration, kind of an early way to loosen up a student's ability to work with a modeling environment to create rich and interesting facades. So I have a few examples of what that second project looks like. So here we make a curtain wall module with different expressions of solid panels or baguettes or whatever the student might choose to design into that. They're required to make a very simplified extrusion in order to understand where the glazing system goes and where an attachment system might go and how modules might fit together. And then onto the building, they look at a rudimentary kind of clip system. And so this is an example. Here's another example of another student and their variation in that system. And then this is a third example of that. So that was the second part of that, and that's currently in the curriculum. And the one that will be introduced this semester is this idea of bringing this facade exploration kind of exercise in, where students can learn a lot of BIM modeling techniques that can facilitate the quick development and exploration of facades. You know, the idea of a punched wall, thick walls, just matching ideas of matching texture to the alignment of window systems so that they can fluidly and quickly model and express their ideas. And the last one here on the far left, the idea of this punched opening, kind of inspired by some work or a project that Boston Valley did. I believe this is Bond Street. They're going to fill me in on this, and I'll add this to the slideshow and give some photo credit to it. But this is a kind of a really inspiring idea of a punched window opening. You know, the idea of reducing the amount of glazing systems in order to be energy efficient. Really a meaningful kind of way of looking at facade development. I want to just take a minute to say there's a lot of inspiration that made me think about this idea of digital mock-ups. One of them is this First in Architecture website, which I get a lot of information. This idea of showing these really rich kind of mock-up details of things. So this is really kind of in the back of my mind when I think about the kind of details that I'm looking for students to be able to do kind of virtually in their own Revit BIM modeling environment. So once again, the idea of the digital mock-up is a learning tool and kind of referencing back to the idea of these physical mock-ups. And this is Boston Valley and terracotta extrusions. And I had the pleasure of consulting with them for many years and kind of inspired a lot of my interest getting back into teaching architecture. And they have in the backyard kind of a graveyard of architectural mock-ups. I say graveyard, some of these projects are in progress right now, but really a rich place for someone to explore. And I've kind of tried to make it a virtual way for students to explore because it's very difficult from our remote location in Alfred, New York, to get to Boston Valley, which is almost 2 hours away. So I photographed a lot of their installations. And this kind of idea to be able to present these kind of virtual mock-up visits and kind of help to set the scale and understanding for the kind of work that can be done with a punched opening type facade. So these are some images from their mock-ups of some facades that they've created in terracotta. And terracotta in a learning environment is lends itself because it's so plastic and its ability to be shaped into almost any kind of configuration. So that leads us to this idea of moving students into making these virtual mock-ups. And you could say, well, why aren't we doing the whole building? Well, that sometimes becomes um, overwhelming to a student. How am I going to make all of these details in all of these locations? So what we've done is by drawing this comparison between the virtual mock-up and the real world mock-up, we've given them somewhat of a manageable bit to bite off, so to speak, in the exploration of it. So on the left here, I have the idea of what would be a virtual mock-up that I've created as kind of a sample for the project or that the students will do, and kind of drawing a comparison between that and the real world mock-up done at Boston Valley Terracotta. And they're not intended to be identical copies of each other, just the same kind of expression. One of the things I found with this idea of doing these virtual mock-ups is that you can also experience them virtually by putting on a headset. And the VR headset offers a great chance to understand the massiveness of the elements that are created. So there's really a kind of a gasping surprise if you've been working on a project for a while, to really see the physicality of it, to see how large the panels you've created and the kind of like physical impact in that kind of a virtual environment. And then we can take that even further with the idea of them being able to deconstruct their own modules or even preconceive them to be modularized and to understand how those might be assembled. So this gives the student the ability to kind of move back and forth between the idea of your idealized facade and the facade that might be realized in the nature of modular construction, which is becoming so popular nowadays. So these are some kind of comparisons. There's a comparison between a complex rigidized assembly on the right-hand side here and kind of the modeling environment, kind of level of detail that I would be expecting in project development that will happen in our next module. So here's some of the original clip systems. Here's some later ideas of extrusions and tile attachment systems. So once again, this area is left for Joe to add some more to the idea of diversity, equity, inclusion. But once again, this idea that digital mock-ups can be built by anyone, anywhere. Our school has a limited kind of facilities in order to do mock-ups. And there are the idea that that's expensive and it requires physical presence of people. And physical abilities of people and participation in it. So this idea of really digging in and starting exploring this digital modeling environment offers a multitude of opportunities. And one of the most is this kind of accessibility, that anyone can participate in it, that can manipulate a mouse and his visual acuity. And so hopefully we'll add there. The idea also too is to prepare students, and I don't have a graphic for this yet, for the idea that this really rich, detailed kind of environment is kind of the start of where they're going to go with digital twins. So being able to see complexity and deal with it will be an important part of their learning experience going forward. So that concludes that presentation, and hopefully we have some time for dialogue now.